True 3D is technically known as stereoscopic vision. Most of us have two eyes looking at the world from two slightly different horizontally spaced angles. The brain merges these two different views into a single impression that we easily take for granted. This process is poorly understood by science. Recreating 3D in computer graphics relies heavily on the description of an object in terms of its depth, width, and height as coordinates. Typically, the Cartesian coordinates are used to describe the position of a point in two-dimensional space, using an x-coordinate for its horizontal position and a y-coordinate for its vertical position. A point in 3D space requires a third coordinate, the z-coordinate, or depth position, forward and backwards. We refer to these as the x, y, and z axes. These axes originate from a point called the origin, 0, 0, 0 in terms of x, y, z, which is the center of our world. This is described as world space or global space. Using this system, the size and shape of theoretical objects can be modeled within the computer. 3D points can be created in terms of their x, y, and z position, and then these points can be joined together to create a wireframe of a 3D object. Objects can be as simple as a cube or a sphere, or as complex as King Kong. Along with this basic principle of constructing an object in 3D space, there are a number of other distinct processes that are required to produce a computer animation. Often these must be accomplished in a specific order. This is called a pipeline. The process of constructing geometry in 3D is usually called modeling. Modeling requires the ability to study the shape and form of an object and find the most appropriate way to turn it into a model within the computer. Modeling is generally divided into two categories: hard surface modeling, geometric shapes such as cars, buildings, and aircrafts, and organic modeling, such as faces, muscles, and skin. By default, a computer model is displayed with a diffuse grayscale appearance. In order to change this outward appearance of a piece of geometry, we need to create what's called shaders and assign them to pieces of geometry. Shaders are materials with different attributes which control how an object reacts to the light and also its environment. These attributes might include things like color or surface detail. We then use textures, or 2D images, in order to control these attributes. To receive a texture map, the 3D surface of a model has to be unwrapped to create a 2D flat canvas called a UV map. The image on the right that you can see is the unwrapped UV map of the previous slide's image, the plane. This UV map is then used as a guide in order to paint a texture. Creating textures to be used in texture mapping is an art form in itself. 2D image manipulation software and increasingly real-time 3D texture painting packages are used to combine, manipulate, and augment photos in order to create the textures that are mapped to the geometry. Closely associated with animation, rigging takes geometry and makes it suitable for animation. This can range from simple constraints to a full character muscle system. Animation is the process that brings our 3D geometry to life. 3D animation involves manipulating the physical position of an object over time. Time is displayed via a timeline, in which each second is divided into frames. Just like filming anything in real life, digital scenes must be lit with combinations of lights and lighting techniques. Lighting involves understanding the technicalities of digital lights, but also the subjective awareness of how to use lights for mood or for storytelling. The last process in the pipeline is rendering. Rendering is a series of complex calculations that converts the digital scene via a camera into a high-quality image, or in the case of animations, an image for every frame, resulting in an image sequence that can then be played back as a moving image. Outside the syllabus of 3D Foundation, there are also more specialist parts of 3D that often appear in the production pipeline. These might include dynamics, physical simulations such as hair, fur, cloth, or particles, tracking or match moving, recreating a virtual camera that copies the movements of a real-world camera, allowing us to perfectly match our computer graphics to live action or film. Compositing, the process where renders and live action can be combined and also augmented in 2D. It's worth bearing in mind that 3D is used in many different industries, and therefore there's many different flavors. These might include the film industry, commercials, TV and broadcast, games, architectural visualization, and product design. The way in which 3D is used in all of these different areas might differ slightly.